In today's episode of Concrete Injection Made Easy, I discuss sealing expansion joints with my guest Dennis Wagner. Who is a product manager of injection products at Normet. We explore a common problem on the job site, which is typically caused by mistakes with installing water stops, namely leaking expansion joints. When it comes to injecting resin to fix leaking expansion joints, there are three options. 1. Injection into the structure. 2. Injecting between the structures, meaning into the expansion joint itself. And 3. Injecting outside the structure. When to use which is of the key consideration whenever sealing out or to repair a leak. Today's episode of Concrete Injection Made Easy gives you key tips and tricks to help you choose the right method for sealing a leaking expansion joint. Make sure you hit subscribe if you haven't already and sit back listening. This is Dennis Wagner from Normet. Today we are going to discuss some very difficult and unfortunately very common mistake on the job sites, meaning the leaking expansion joint. Why it happens that we can see this kind of failures so often on the site?
It's a good question, many problems can occur in an expansion joint. One, especially when water stops are used, as you know, is that the water stop itself is not attached properly. That's one reason. Another reason is that it attached properly but destroyed after it is attached. That can happen. And what you see on sites, storage of the water stops can be a problem. So that when it's stored on site, that someone else is destroying the water stop, driving over with a forklift or whatever, depending on the material. Also, that the water stop just is laying around several days, weeks, months, or whatever. Then
before it's used.
Yes, actually, just laying in the sun, laying in the dirt, whatever. So that can happen, and that happens, of course.
So, like you mentioned, at least three different possible mistakes and the causes of the leakages. How can we tell which one is actually true? Do we have to tell it before we start to fix the leakages?
It's the best way to fix a problem is, of course, the source of the problem. But as you know, sometimes is it when it's attached already and it's in the joint, let's say, and the problem occurs later on, it's sometimes not even easy to see where actually is the problem.
Yeah.
Because there's water coming, there's dirt coming. Yeah. So let's say cleaning first is, one of the major things you have to do, and make an observation. What is the problem? But even that, sometimes it's hard to say, because if it's already leaking, and even if you clean it and water and dirt is coming again, you will not see so much.
Absolutely. There is also one more factor. Like from my point of view as an applicator, it seems that I'm being called to have a look at this leakage, not the very first day when it's occurred. Sometimes they call to repair it 2 or 3 or even more years, not days, years after the leakage started. So you have the very narrow expansion joint, like 2 centimeters, filled with the some dirty stuff. Let's don't mention what's there, because different things can be found inside of the expansion joint, including the concrete. And so it's not that easy to have a look inside. And as you mentioned, even though we remove this dirt, it can be still very difficult to tell where exactly to exactly tell where this point where the water is coming, where is it located.
Exactly.
So you mentioned that the water stop can be installed in the structure. I mean, in between halfway of the thickness of the wall or the concrete slab. Is it the only place where it can be installed?
No, actually not. There are different water stops on the market, of course. It can be an external or internal joint. Sometimes what can happen also is that there is even no water stop or expansion joint attached, even if it should be attached.
So let me ask, if there is no water stop, what is this that should stop the water from coming into the structure?
Exactly.
Nothing.
So nothing. Or there was like, if there is an external one which should be attached, but doing excavation work or whatever, it can be destroyed also. Not because there is no expansion joint attached, but it gets destroyed, So it can be digged away with an excavator or whatever, or something else happened if it's an external one. So it is just gone, let's say. So there is no expansion joint anymore. Can happen as well.
Okay. So let's say that we are on the job site. Let's imagine that we are standing in, let's say, the underground parking place, and we can see the water coming through the expansion joint. This joint is like 35 meters long, and we can see at least 5 or 6 different places where the water is leaking from it. What would be your best advice to designers and applicators listening to this conversation, how to approach this situation? What would be your first step?
The easiest way, of course, if let's say there's an expansion joint and you think that the expansion part itself is okay, let's say. So the part the sealant which is placed in the concrete is maybe damaged. You can make a drilling there, just to hit it on the part in the concrete. And of course, if you hit it, you will, let's say, see it because of when you drill, you see first just the dust from the concrete is coming out, and then you will maybe see, then you know that you hit it, you feel it. You can feel it actually if you're experienced driller, let's say, or you can even see it because you will hit the rubber a bit.
Absolutely, yeah. Then you will feel that this dust is different than the pure dust of concrete, especially when you drill in order to hit it. Then you expect that something will be changed during the drilling process, and you expect the dust to be different in a couple of seconds.
And actually you feel it because if it's destroyed there, also the concrete in that positions is sometimes not the same quality, of course, like above. So first you feel it that you're drilling the concrete, and then it, let's say, moves a little bit forward. Then you hit, let's say, honeycombs or whatever. So your drill bit,
a little gap, like no concrete at all in around of this place where the water stop is being attached to the concrete. Okay, so what do you do when you have this holes drilled? How many holes, by the way, like per one running meter?
That depends actually on the concrete slab's thickness. Yeah, and then you need to have you need to hit it from both sides actually, most probably. What you do then when you drill it, of course, it's one of the most important things, and I see it a lot that people are not doing, is it's cleaning the borehole actually. Clean the dust out. You can make it by air or even by water to clean it so that there is no dust, no particles inside the borehole, which can block actually doing the injection.
Okay.
And then you can go on, place a packer and start to inject. And then observe actually what is happening. If you see like the pressure is directly going up, then there is no chance to inject. But if you see that you can inject material into the concrete, then there is space or voids inside the concrete that need to be filled. And also you may see that the material you're injecting is coming through the expansion joint itself, then you know that there is a way that you actually now blocking, and that's also the way where the water is coming through. Because actually what is happening, you have the movement joint. So the water is coming from the other side. It penetrates through the joint itself, hits the water bar, and then the water bar itself extend the way of the water. So make the way longer, let's say, that it cannot penetrate anymore. There's a way where there is enough space that the water can penetrate, it will come out of the joint. And it would be the first step. If you can hit it on that position, you don't need to drill external to the construction part. You actually drill onto the water stop itself and then inject and seal the way so that the water cannot penetrate anymore.
Do you think it's possible to observe the resin coming into, through this first pucker you are injected into, through this gap between the concrete and the water stop to another hole being drilled like 25, maybe 30 centimeters away, and then you can see this resin coming through another hole, another pucker?
Of course, it can happen. Then you know at least that you're filling it properly to your next pucker, which is actually what you should do if you have, let's say, 3 packers.
That's what I mean. It gives you the perfect control over this injection process, right? Then you know that this space between one and the following pucker is really filled with the resin. Yeah, I love this because the injection is the play of imaginations. You have to imagine what can happen with the resin after it goes from your pump, from your hopper of the pump, then somewhere in the concrete into the structure. So when you see it coming from another pucker, it's great information for you that you know where you are, and then you realize that what you are doing makes sense.
Exactly. Same when you inject into cracks, that's why the first pucker, if you see the coupling you have for your packer, it should be unscrewed. So actually that the way is free. Exactly. So just connect the first pucker with your, let's say you have a slide coupling or whatever, connect it and leave the other packers open. First,
exactly.
I'm really
happy to hear this. Oh my,
Yeah, many people don't do it. They close it first.
I would love to ask the packer producers, why do they sell the already screwed packers with these two parts, the packer itself and the nipple? Why is it? Why they don't sell it separately?
But you see it also. If you go one step back, if you decide what equipment you need, there are also cheap packers on the market, where is it already attached by. There are also good manufacturers of that packers where it's unscrewed, because also you can change. You have a zerk coupling maybe, or a slide coupling, whatever. But there are two reasons. One is you see that the material is traveling, but the other way is also if you close it, the system is closed and the pressure just goes up. You need that for relieving the pressure so that the material can move. And if the pressure goes up, you see it also.
Exactly.
Many unexperienced, they just go on. My pump can pump with 200 bars, and they go on with the 200 bars. Actually, you know what happens? You're destroying more than you fix.
Absolutely, I agree. Okay, so this is the first the first way of sealing the expansion joint is to drill and to inject the resin into the concrete right next to this place where the water stop is attached. Let's discuss the second situation where we can somehow tell for 100% that the water is coming through the expansion joint because the water stop doesn't exist or is broken in this place where it was supposed to move with the change of the width of the extension joint. How can we fix this in this kind of situation? Like we inject where? What do we do?
The thing is, there are two ways to do it actually. One way is, let's say, if we have moderate to slight water ingress, then you can just drill in an angle to hit the spot behind the damaged part and to fill just the gap between the slabs. But if the water ingress is too high and it's not manageable, what you need to do is to make like a ground curtain behind it. And
ground curtain, what's that?
A ground curtain is that you drill through the concrete itself.
All right.
Yeah. And inject behind it, so that there is a complete curtain behind the concrete structure.
I see. So you inject the resin out of this structure into the ground that it's connected with the wall or with the slab that being sealed.
Exactly.
I see.
But this is just possible if there is something behind. Yeah. That's the main thing, because you need to then inject into the soil, and maybe we have something where you cannot inject behind it, and that you need to check. And that's kind of the informations you need to have actually, because before you start, you need to have a lot of information about how.
Once again, every single conversation I have on site starts with gathering as much information as possible to really not know what you are doing. So the information allowed you to make a better decision.
That's the main thing where it should start. You need to know, is it an internal or an external expansion joint? Do they maybe know what could be damaged because they already damaged it during the construction phase, and they know they damaged it, but they just go on. So also it's important what kind of expansion joint, which material is it made of? Is it PVC, is it PE or elastomer? So maybe some of the materials they use is not reacting in a proper way with that material, so you can maybe destroy something. So did they make any injections before? Is there any drawing of the construction part? What is below? How much movement is expected? Also, that is one of the important question, because your material, if it's flexible, it should be the same. Should have the same flexibility as the movement joint itself. If it moves few percentage and your material is rigid, makes no sense at all. That are all the things you need to know. Also, if there are any local restrictions, like in regards on the environmental requirements, do we need an approval for the material? In regards to, is it like maybe there's drinking water
or the groundwater, right?
Exactly.
I see. Can you tell us a little bit, like in your opinion, let's say that the decision is to really inject the resin out of the structure in the ground. What would be the best reaction time for this resin to set before we start injection?
That depends, of course, on the soil you have and how much you want to penetrate into the ground. And that's also very important, because one issue is if it's too fast, you don't have a proper ground curtain, which you need. If it's too slow, you can have the problem that it's just spreading somewhere. So that's another information you should have, is what kind of soil you have outside. Is it loose sand or gravel or whatever? And then the decision is easier to do it.
Okay. Can we say that the spacing between the holes and the packers later installed in the holes should be the packers should be closer to each other when we inject outside of the structure, comparing to the first described situation where we inject into the concrete? Like,
I would say the meaning is that the raster or the pattern you have should be always more or less similar, because what is necessary is that you need to assure that the spacing between the packers are in a manner that you're assured that the material is spreading enough. And again, that depends also on the soil you have, and then you can adjust the raster you have.
Okay.
Or the grid.
So can we give our listeners an average, or it's impossible to give a number?
I'm not a friend of average stuff, actually, because there is too much stuff that can go wrong.
Okay.
There are, of course, like if you go for crack injections, you should drill half from the crack away, half the thickness of the concrete structure to hit it halfway of the crack in a 45-degree angle, stuff like that. But I'm always a friend in taking a look what actually is on site, what are the conditions, and then decide it. Because otherwise, people hear, oh, there's an average distance. They just heard it and misunderstand it, and then they heard 15 centimeters and they just go 50 centimeters everywhere, you know.
I know. I heard the same story about this angle of 45, where they choose to drill at the angle of 45, but they drill right into the crack. So they just miss the crack because they didn't start to drill in the place where they should have. So, but the angle was right, 45. Yeah. So like,
you never know what's in the ground, you know. So the crack can be shifted. It will not be a straight crack. So that's why that 45 angles and then hitting it from left and from right side from the crack assures also that you're always hitting the crack. If you don't hit it from the right side, you will hit it from the left side. Depends on how the crack is shifted, you know. If you go somewhere and you see that some people drilled into the crack, more or less, for me, that's my personal opinion, you know that there were guys, they don't know actually what they are doing.
Yeah, I have pictures of that kind of this kind of injection. And water was coming again, even after the injection has been, finished, because they simply didn't fill the crack at all. Okay.
But to show someone, you know, that material is coming outside of the crack, and that's why people are doing it. You know, let's see that we have a good injection, we drill into the crack, and then you have someone who don't know what you're doing, you show them, or you see that the material is coming out of that crack. And they see, oh, okay, it's filled. But normally we say that you need to fill a crack like at least 80% to have a permanent sealing of a crack. So the surface filling will make no sense at all.
Absolutely. Okay, coming back to this expansion joint, we discussed this injection where we have water stop somewhere inside of the, let's say, halfway of this concrete, meaning internal sealant, and we have injected into the ground. Okay, this is understood. I can only say that the consumption of the resin is much higher in this solution. What about the situation that we are able to inject the resin into the expansion joint?
You mean when there is an external expansion joint, or when is it in the middle?
In the middle one.
Okay. Yeah. The consumption is of course lower. Yeah. And if there is no high water ingress and it's manageable, that should be the first choice, of course, because, like I said, the consumption is higher and you don't penetrate through the complete construction part. It's an easy way. And I would also just go and really drill complete through the concrete part. When you see there is no other chance, you know, then you need to make the grout curtain with higher volume, of course, you're using.
Yeah. Okay. So, what are the steps in order to run the proper injection that you inject the resin into the space, into this between the structures, or let's say into the expansion joint, in the situation where you mentioned before, when there is no sealant at all, how to run this, how to prepare this joint to inject resin.
Okay, when there is no joint at all, what is necessary there is, of course, again, the proper cleaning of it, and then you should use some kind of plug to make sure that the material is really injected in the expansion joint. So there are different kind of materials on the market, like rubbers or similar stuff. So you can put one of the rubbers, try to pull it from the surface to pull it down as much as possible. So you can also prevent that the material is just floating behind. And also you can take one of that plugs on top of it, and then you drill and try to hit it in the middle, fill it up with material.
Okay. So you prepare the well prepared, well cleaned space in the expansion joint, and in the space there will be resin injected and glued to the walls of the expansion joint. How to make sure that the walls are really clean?
You cannot make sure that it's completely clean, but with the help of a proper material like PUs, they will not have a problem with adhesion. And if you take an acrylic, which would be my choice also, it's a swelling material. So some companies, they sell their acrylics and say that is an adhesive material. Yeah. Actually, if you look like into the European normings, what an acrylic is, the sealing effect is coming because of the swelling capabilities of the material. And then it's not necessary that the surface of it is clean, because you cannot get rid of all of the construction stuff, which is already on top, dirt, etc. And the swelling of the material itself, that is actually the sealing effect of an acrylic material. And like I said, therefore, you don't need an adhesive product.
Okay. Let's say that
was just the one of the ways, of course. The other way would be, again, like before, to make that grout curtain if there is no sealant at all. So drill again through the segment and make an injection behind the structure to make sure that there's
we still have two options. We inject into the joint, or we drill through the concrete and we inject the ground that it's right next to it.
Exactly.
Okay, I understand you. The question is about this swelling. I had a situation like maybe 3 years ago that we have really filled the expansion joints. The concrete was 35 centimeters, the thickness of it.
Okay.
And we have filled almost 20 centimeters of this 35. And can you imagine then 1 year later, in February, maybe March, and there was heavy raining in this region, and this acrylic gel, swelled so much that you could see it, on the surface of the concrete. So the volume of this resin really rised so much. In your opinion, did we inject too much of the resin into this joint?
I wouldn't say too much, because actually what the resin did was what it's supposed to do. So it swelled after water was coming again.
Yeah, but the client wasn't happy to see the resin, being outside. They really thought that something was wrong with this.
Actually, like I said, it's nothing wrong. But what you can do is, and I would go for that also with the latex reinforced acrylic or acrylate, where you use the instead of water on the B side, you use a latex. It's different names, also elastomer or whatever the competitors also calling it. And you reduce the swelling effect with that. That's also one of the advantage. And especially for movement joint, that material can make more movement than a normal acrylate. And I think that you wouldn't have a problem if you use that reinforced material. Depends on the brand, of course. They are also different on the market. And what be the other, if you know what happens with that material, you need to close the joint also, because what you can also do is try to attach like a water stop exterior, from inside where you're working. that could be a solution as well.
Okay. You say that the way of stopping the water by this acrylic materials is swelling, but there are also.
I'm not saying the norm is saying that.
Once again.
The norm is saying that. If you go to the
norm
1504.5, that is saying that the acrylate is sealing because of the swelling effect.
I see. Can you say that what is the minimum size of filling this expansion joint gap, like 10 centimeters, 8, 5? What is the minimum amount of resin in height of this to feel free after injection? Like, yeah.
The height is because you have different slabs. I would say the percentage.
Okay, let's do it in percentage. Sure.
I'm not sure if there's anything on the market written what they're saying, but I think we can go with the norm of crack injections with this 80%, which assures a proper sealing and a permanent sealing. And if we go with that, I think we are on the safe side. Of course, you're filling it more than normally when you have the proper water stop inside.
Okay, 80%. I checked if the concrete is 35, so the 80% of it is 35, 28 centimeters. I think that's a little bit too much. Well, that's my opinion. I would stay with like 10 to 12 centimeters of the filling height of the joint should be enough.
So 30%, roughly.
Like, yeah, more or less. In my opinion, it's really enough. We installed this acrylic gel as close as possible to the external part of the wall.
Yeah, definitely, because that's where the water is coming from.
Exactly, and the first water that hit the acrylic gel, that it's hardened into this joint, keeps it flexible, keeps it, let's say, alive, the resin. And it may happen that only first 2 or 3 centimeters of this acrylic gel really fights against the water, and the rest is like, waiting for its chance maybe in the future, some years later. So this is my private opinion. You can have your own. I mean, our listeners can also have the same their own idea of it. But this is how I see in my imagination how this sealing of the expansion joint works.
Of course, and makes sense also if you see that you had the problem before with materials swelling out of the joint. Actually,
yeah, we were trying. I think we were trying to be too accurate, and on this construction site there was a high water level in the ground, so we were trying as much as possible to really avoid any mistakes, and we did it. And
perfect.
That way, as I mentioned,
it's always the most important part. In the end, it needs to be dry.
Yeah. Afterwards, when the job is done. So we have discussed the internal sealant, the external sealant, and no sealant situation on the job site. We've covered the topics of injection in the ground, in the structure, and between the structures, meaning in the expansion joint itself. Do you think we should say anything else to have this topic really covered?
just from my experience, I'm not sure if you agree, is really to do that, because some people also go on with a polyurethane. There are also flexible polyurethanes on the market, which I quite like, I need to say, because there's a lot you can do with that kind of materials. But anyway, I would go there with an acrylic resin and reinforced with a latex or elastomer component on the B side. That would be
on the B side. So there are some acrylic gels that allow you to use tap water, and the tap water can be exchanged for this elastomer. So when I inject expansion joint without any tap water, only resin.
Yeah, but that's what I mean, huh?
Yeah, exactly.
So no water
That's
on the B side, also the reinforced material. Exactly.
Okay, so I agree.
Perfect.
So yeah, I think we managed. It's like, easy to discuss and hard to really make it happen. In my opinion, injection of the expansion joint is one of the most difficult injection job. How do you find it comparing to other injections?
It's a good question, because fighting water is always tricky. Even a smaller crack can sometimes be tricky. But I've fought also against really high water inflows in tunnels and mines, which can be also very tricky and also exhausting, because you're in remote places and in, let's say, cold conditions, or sometimes really hot conditions, and you have a resin rain when you start injecting stuff like that. But just my opinion is always that the fighting water is always a challenge, because viscosity is very low, and water, it always finds a way. And
the water has time and is very patient.
That's good words. And also what can happen is, we know it, Matthias, you know it, I know it. You stop it on one position, and then it can start flowing. Yeah,
from another one.
2 meter away, it starts flowing, because it's always following the easiest way, or it's going on the weakest position. So if you close one, it will maybe find another position where it can easily.
Oh my, that's so true. That's so true. It happens so often that you are happy to finish your job site, and then you have to come back because they found another. I mean, the water has found another way to come in
Exactly.
to the same parking place, but 20 meters away, and then the story comes once again. Okay. I'm pretty sure that our listeners would love to contact you, that they have some, issues on their job sites. How can we find you on internet to just, ask you a question, maybe, have a meeting with you on the job site?
First of all, it's always okay to drop a message by the mobile phone, WhatsApp, or a normal message, or give me a call over my mobile number, which is 0049 170 7789 320.
All right.
I'm on LinkedIn, Dennis Wagner, DENNIS WAGNER, or just send over an email to dennis.wagner@normet NORMET.com.
Great.
Just up for any conversation.
I will put this information in the notes of this episode of Concrete Injection Made Easy podcast, so everyone can find your phone number, your email, and your LinkedIn account, so they will able to find you quite easily. I'm really happy that you have found time to have this conversation with me, and I'm looking forward to hear some questions and comments on this conversation from our listeners.
Matthias, it was my pleasure. Thanks for inviting me, and I'm always up to exchange knowledge and different ideas between experts, which was quite interesting for me as well to exchange ideas and thoughts with you, because you also have a lot of experience, and you know, the experience on the field, actually on the site, that's the most important thing. Because you know, you have a solution there and you go to the next site and think you have a solution, but maybe everything is different and you need to rethink again what you have done. Absolutely. And find another way.
But the more you know, the easier is to find another solution for different, little bit different story on another site.
Definitely.
That's it. Super. Once again, thanks a lot for the conversation, and see you soon. Bye-bye. This interview is super. There is a huge amount of explained issues, especially this part where Dennis says about what info you need to collect to be able to seal an expansion joint, and this one where he explains why to use open packers. It's so important. Actually, I prepared an education email for all my subscribers covering exactly this topic. Now, it's up to us designers, applicators and suppliers to take the best possible solution suited to the job site conditions. Thanks for listening, remember to subscribe, and I hope you tune in next time.